Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll review everything you need to know about compound interest for the upcoming test. So we need to be able to understand the difference between simple and compound interest. So let's say I invest $20,000 at 5% per annum, which means per year. So if I am achieving simple interest, my investment will go up by $1,000 each year because 5% of 20,000 is 1,000. So after the first year, I'd have 21,000. After the second year, I'd have 22,000. After the third year, I'd have 23,000 and so on. But it's not quite the same for compound. Let's say that I invest $20,000 at 5% per annum and interest was compounded annually. That means they recalculate the interest that you've earned at the end of each year. So in the first year, I would still earn $1,000 interest because 5% of 20,000 is 1,000. But for the second year, I would increase 21,000 by 5%. So increasing by 5% is the same as timesing by 1.05. So 21,000 times 1.05, I get 22,050. So now at the end of third year, I'd take 22,050 and I would increase that by 5%, which is the same as multiplying by 1.05. So you can put that on your calculator. You get 23,152.50. So we saw that for simple interest, the amount I have goes up by the same amount each time. For compound interest, it went up by 1,000 in the first year. It went up by 1,050 in the second year. And then in the third year, it actually went up by $1,102.50. So for compound interest, the amount you have increases at an increasing rate. These numbers are going up each year. So not only is your investment growing, but the amount by which it grows each year is also increasing. So if we were to look at a graph of these, they would start here at 20,000. Simple interest is linear. So simple interest is this blue graph. Goes up by the same amount each time. On the other hand, compound interest is exponential. If you were to graph the amount you have on the y-axis and the x-axis is the number of years after you've invested, it would go up like this. It goes up much, much quicker at an increasing rate. All right, let's now look at a problem where we'll use formula to calculate interest. So let's say I invest $5,000 at 2.4% per annum. How much more would I have after 5 years if interest were compounded monthly rather than simple? So this is the simple interest formula. This is the formula for compound interest. Just note that they calculate different things. This formula for simple interest calculates how much interest you have earned, and this for compound interest calculates the amount to which your investment has grown. So let's start with simple interest. So for simple interest, if you invest $5,000, P, the principal, is 5,000. R, the rate, is 2.4 because it was 2.4% per annum. And then we times that by T, which is 5, for 5 years, all over 100. So if you put that straight on your calculator, you get $600. If interest was simple, you would earn $600 in interest. So the total amount you would have after the 5 years is $5,000, which you had originally, plus the interest you've earned, which would give you $5,600. So what about if interest were compounded monthly? So we're going to use this formula here. But just note, when you're using this formula, if the compounding frequency is not yearly, is not annually, you need to change R and N. So when I want to use this formula, P will be 5,000, that's the principal, but I have to change R because R is 2.4% per annum. Compounded monthly means you recalculate how much interest is earned at the end of each month. So if R is 2.4% per year, it will be 2.4 divided by 12. It will be 0.2% per month. Of course, I divided by 12 because there are 12 months in a year. Now, n here in the compound interest formula is the number of times that the interest has been compounded. So if it's compounded every month, it's compounded 12 times a year. So 12 times a year for 5 years, in total, it will be compounded 60 times. So you only need to change R and N like I did here when the interest is not compounded annually. If it were compounded quarterly, we would have divided by 4 here times by 4 here. If it were compounded daily, we would have divided by 365 here and times by 365 there. So you only change R and N when the interest is not compounded annually. So now we're ready to use the formula. So we have the amount that we'll have is 5,000, the principal, times 1 plus R. So we decided R was 0.2% per month. R over 100 to the power of N, which is 60. So if we put that on our calculator, we would end up getting $5,636.81. So when you're giving money, either round it to the nearest whole dollar or to 2 decimal places. So if we keep the same interest rate, same principal and same time, you always have more money with compound interest rather than simple interest. It also turns out that the more frequently you compound, the more money you have. So if it's compounded monthly, you'll end up with more money than if it were compounded annually, for example. So in addition to being able to use these formula, what we need to do is be able to solve for other variables in the formula. So we're going to now see an example where we're finding R from both of these formula. So this question says, I want my investment to double in 10 years. Calculate the interest rate required if interest is simple versus if it's compounded annually. So we should expect, even before starting this question, we will need a higher rate of interest if interest is simple than if it is compounded. So let's start by writing the simple interest formula. I equals PRT over 100. Now we can use this formula to solve not only for I, but to solve for P, R or T. To do that, we just substitute everything we know. So what I'm going to do is I'm going to rub out T, which is time, and replace it with 10, because the question told me that it's 10 years. So I want to find R. You might think this is impossible because I don't know I or P, but it turns out it doesn't actually matter how much you originally invest. If you want your investment to double in 10 years, the rate will always be the same, regardless of how much you originally invest. Because if I want my investment to double, that means I want I to equal P. If I invested 10,000, I need to earn 10,000 in interest, so my investment has doubled. So what I'm going to do is I'm going to rub out the I here, and I'm going to put a P there. So the idea is I can divide each side of this equation by P, and the P's disappear. P divided by P is 1. P divided by P is 1. So what I end up with is 1 equals R times 10 over 100. So you know how to solve these equations. I need to undo what's been done to R in the opposite order to bid mass. So I times each side by 100. I get 100 equals R times 10. Then I divide each side by 10. I get R equals 10%. If you want your investment to double in 10 years and interest is simple, you need an interest rate of 10%. So let's go ahead and calculate this now using the compound interest formula. So again, we should expect that our answer will be less than 10%. I should need a lower rate of interest for compound interest because it grows so much quicker. So here we have our formula. A equals P 1 plus R over 100 to the power of N. So what I'm going to do is substitute what I know. Well, I'm finding R. Now, I know N. If I am compounding annually for 10 years, N is just 10. So I'm going to replace N with 10. I don't need to change N here to anything else because I'm compounding annually. So again, I don't know A and P, but I do know that if I want my investment to double, I want A, the amount I have, to be 2P. If I originally invested P dollars, I want my investment to be worth 2p. If I originally invested 10,000, I want it to now be worth 20,000. So again, I can use the trick that I used up there. I can divide each side by P. So what I'm left with is 2 equals 1 plus R over 100, all to the power of 10. Now this is a tricky equation to solve for R. What we need to do now is undo to the power of 10. To do that, you actually take the 10th root of both sides. So the 10th root of 2 equals 1 plus R over 100. So putting the 10th root of 2 into my calculator, I get about 1.07177. I want to use a lot of decimal points here because I'm going to use this number in the next step of the calculation. So I need to solve this equation. What I need to do is now subtract 1 from both sides. So I'm going to end up with 0.07177 equals R over 100. Now I'm going to undo dividing by 100 by timesing each side by 100. So I just put this number times 100 in my calculator and I get about 7.18%. So both of these are per annum because the original question was in years. So I would only need a rate of 7.18% for my investment to double in 10 years if it were compounded annually. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.